Hey Calculus, today we are going to talk about limits that involve infinity. That means they're either approaching infinity or they are equal to infinity or both. So let's look at the first type, infinite limits. These are limits that are equal to infinity or they're equal to negative infinity. So right here I'm going to highlight this. They are equal to infinity or they are equal to negative infinity. So let's look at the graph right here. We want to find the limit as x approaches 4 from the left. So I'm going to put in my imaginary line through 4, and I'm going to trace the graph coming towards that line from the left. So that is like this right here. I'm coming towards that line. My graph is going up and 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 up, and that's called infinity. When a graph goes up and up and up, the y values are getting bigger and bigger. So that is equal to infinity. Okay, now you'll notice that this line right here, the line y is equal to 4, is a vertical asymptote. All right, so that's what goes right here. The line x is equal to, the line x is equal to 4 is a vertical asymptote. Okay, infinite limits, limits that equal infinity or negative infinity, will always have a vertical asymptote. That's how you can kind of pick them out. That's a big hint if there's a vertical asymptote. All right, and that's what we're talking about right here. If the limit as x approaches c is just whatever x value you're approaching, of your function is equal to whatever it's equal to, then the line x is equal to c is your vertical asymptote. This right here is where your vertical asymptote will be. Okay, if you notice up above, we are approaching, x is approaching 4, and that is where your vertical asymptote will be. Okay, so again, infinite limits are limits that equal infinity. The graph is going up and up and up and up, or they are equal to negative infinity. The graph is going down and down and down and down. All right, that brings us to our second type of limit that involves infinity, and that is limits at infinity. All right, limits at infinity. These limits are approaching infinity or negative infinity. You'll see infinity right under here. X is approaching infinity, x is approaching negative infinity. Let's look at this problem right here. What is the limit as x approaches infinity? As x is approaching infinity, x is getting bigger and bigger and bigger. Think of a number line. On the x-axis, going to the right, the x values get bigger and bigger and bigger. So that's the hint for finding these limits. If x is approaching infinity, you trace the piece of the graph that's going farthest to the right. For a limit, you always trace the graph. If x is approaching infinity, you trace the piece of the graph that's going farthest and farthest to the right. So that's this piece here. I'm going farther and farther and farther and farther to the right. Right here, the y value is 3. So this is getting closer and closer and closer to 3 as I get farther and farther and farther out on the x-axis. Okay, now let's look at the next one. Now x is approaching negative infinity. That means the x values are getting smaller and smaller and smaller. On the x-axis, that is to the left. Going towards the left, x is getting smaller and smaller. So if x is approaching negative infinity, you trace the piece of the graph going to the left. And on over here on the graph, this is the piece that's going to the left, and I trace it going to the left. And right here, it's getting closer and closer to that y value of 3. Okay, so again, as I go to the right, my y's are getting closer and closer to 3. As I go to the left, my y's are getting closer and closer to 3. What do you notice right here at 3? This is a horizontal asymptote. If these limits exist, approaching infinity or negative infinity, there will be a horizontal asymptote there. And that's kind of your hint. Okay, limits at infinity, x is approaching infinity or negative infinity, will have a horizontal asymptote. If the limit as x approaches infinity of your function is equal to L, then the line y is equal to L is your horizontal asymptote. This right here is where you will find your horizontal asymptote, what it is equal. Right here, the limit is equal to 3. That's where the horizontal asymptote is. Same thing right here. This limit is equal to 3, and that is where the horizontal asymptote is. Okay? So, let's go through it again. If your limit is equal to infinity or negative infinity, there will be a vertical asymptote. Your vertical asymptote is what you're approaching. If the limit is approaching infinity or negative infinity, there will be a horizontal asymptote. The horizontal asymptote is the answer. That's what the limit is equal to. Right down here, this is just review. So let's do these in blue. The limit as x approaches 2 from the left. So let's put in our imaginary line at 2. Let's trace the graph coming towards that line from the left. And that's this piece right here. The graph is going down, 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 down. So that is equal to negative infinity. The next one, the limit as x approaches 2 from the right. Now we come towards this line coming from the right. That's right here. I'm tracing the graph. As I get closer and closer to my imaginary line, my graph is going up and up and up and up. So that is positive infinity. The next one, what is the limit as x approaches plain old 2? Well, this is a horrible date. The left is going down, down, down. The right is going up and up. Doesn't get worse than that. So the limit as x approaches plain old 2 does not exist. The left limit does not equal the right limit. Okay, let's go to our third type of limit that involves infinity. Infinite limits at infinity. Here you have both. You're not only approaching infinity or negative infinity, your limit is equal to infinity or negative infinity. So here's some easy examples, and you guys have been doing these for a long time. Right here, this parabola, as x approaches infinity. All right, x is getting bigger and bigger. You trace the graph going to the right. This is the piece of the graph going to the right. It's going up and up and up and up. That one is equal to infinity. The next one, x is approaching negative infinity. X is getting smaller and smaller and smaller. So you trace the graph going to the left. This is the piece of the graph going to the left. It's also going up and up and up and up forever. So that is also equal to infinity. So a parabola is an example of a graph that has infinite limits at infinity. It's approaching infinity, negative infinity, it's equal to infinity. The next example is our absolute value graph. The limit as x approaches infinity. X is getting bigger and bigger. You trace the piece of the graph going to the right. As you trace the graph going to the right, it's going up and up and up and up forever and ever and ever. That is equal to infinity. The next one, x is approaching negative infinity. X is getting smaller and smaller and smaller. You trace the piece of the graph going to the left. That's this piece. As I trace it going to the left, it's also going up and up and up and up. So that is also equal to infinity. Third example of infinite limits at infinity, our cubic graph right here. All right, as x approaches infinity, trace the piece of the graph going to the right. That's this here. As I go to the right, it's going up and up and up and up and up. So this is equal to infinity. Now, as x approaches negative infinity, x is getting smaller and smaller and smaller. I trace the piece of the graph going to the left. As I trace this, it's going down, 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 down. The farther to the left I get, it's going down, down, down. So that is equal to negative infinity. And finally, our linear function is another example of an infinite limit at infinity. As we're approaching infinity, as I trace the graph going to the right, it's going up and up and up and up. So that is positive infinity. As x approaches negative infinity, as I trace the graph going to the left, I trace it this way, going left, left, left. And I know my arrow is in the wrong way. Hold on, let me change that. Okay, now as I trace the graph going to the left, just look for the red dot. As I go to the left, it's going down, 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 down. So as x approaches negative infinity, the graph is getting closer and closer to negative infinity. Okay, those are limits that involve infinity.